Today we are going to discuss triangle chapter. In this triangle we are going to study similar part. So what is meant by similar? So consider the 2D dimensional shape: circle, square, rectangle, triangle, regular, polygon, such that extra. Now in that circle we have a property radius, diameter and arc. If we have different radius, we have the one shape. That shape is never going to change. 5 centimeter radius of circle, 10 centimeter radius of circle. Similarly, in that square angle 90 degree in the each vertex, and sides 4 centimeter side square, 10 centimeter side square, like that. Similarly, rectangle, triangle, regular, polygon. Now in this shape we are going to study the similar property. In that similar, same shape, not necessarily the same size, no need. And in that congruent, same shape and same size. So what is meant by similar? In that similar, same shape is necessary. Same shape is not necessary. Same shape but not necessarily the same size. Circle means circle. We can compare circle with the circle, not circle with the oval, like that. Square with the square only. So this thing only we can tell about that is similar. In that similar, we already come across many examples. Here consider these two bottles. These two bottles are already, wherever you rotate, just whatever the rotation, whatever the shape. So by looking that these two things are same size and same shape, but in this two things are different now. So one is bigger one, another one smaller one. Here also bigger one and smaller one. Now we can consider each and every part of this thing. Here these two things are congruent, but these two things are not congruent. So now we are going to study about the next property. But anyway, these two things are similar, somewhat similar. Small size, bigger size. Small size, bigger size. Okay, so congruent, similar and similar. Small size only. So now come to the 2D dimension. This is a concentric, like a concentric circle. Small circle, bigger circle. These two circles are similar. Square. These two things are similar. Small side and bigger side. These two triangles are similar. These polygons are similar. So we are going to consider that property of the similar. In that two polygon of the same number of sides, triangle, hexagon, pentagon, nonagon, decagon, that polygon, the corresponding angles are equal and their corresponding sides are in the same proportional. This thing we need to prove the similar property. So similar property means this thing. So suppose it's a square, this automatically this angle is 90 degree, this angle is also 90 degree. So using this we can tell these two things are similar. So this is necessary angle and then sides are in the proportional. Suppose the same enlarged thing, it's a photograph, you know that small size, bigger size. So small size, after that bigger size. These things are similar. So we can write that each and every angle and also the sides proportional. This we can tell half of this photo, half of the size, or 3/4 of the size, like that we can tell. Okay. Similarly, we are going to study the similar property. Suppose pictures in that book given, no, 85 degree, 85 degree, 70, 70, 105, 105. All the angles are equal, definitely. But the sides 2.1, 4 point, doubled. 2.4, 4.8, 2.5, 5, 1.5, doubled. Automatically it's equal. If any one condition fails, automatically these two things are not similar. Suppose it's 2.5 here, 4.5 means these two things are not similar. Not only this shape, we can rotate this also. After that we can check. The same way, angle 90, 90, 90, 3, 3, 3, 3. Check 3.5, 3.5, 3, here 3.5, 3, 3.5, but 3 by 3, 3 by 3, so it's different, no? 3 by 3.5, 3 by 3, it's different, no? So these two things are not similar. Automatically here 2.1, 4.2, 2.1, 4.2, these two things are similar, but angle here in that square, that angle 90 degree, but somewhat rhombus, that angle is not exactly 90 degree. So these two things are not similar. By this we are going to study that exercise 6.1. All circles are congruent, not possible, because it's not same, so similar. Similarly, all squares are similar or congruent. All squares are definitely similar. Suppose in that first question, all circle with the same radius means answer congruent. All squares with the same sides means it's congruent. Only given all circles. So all similar, all squares similar, all rectangle similar. Similarly, all regular hexagon, all regular pentagon, all regular, that is equilateral triangle, or similar equilateral triangle. In that regular polygon, all the angles are equal, sides length may be proportional. So in that things we can tell. So consider not only these two example, we given that example also. Now all equilateral triangles only similar, isosceles triangle it's not similar. That angles may be equal, but sides not possible to equal. Two polygons of the same number of sides are similar if their corresponding angles are equal, their corresponding sides are proportional. We already studied, we need to substitute this. Give two different examples of pair of similar figures. Already we studied circle, square, equilateral triangle, hexagon, pentagon, nonagon, octagon. So that is angles are also equal, sides also proportional. We can give that circle, different radius circle. In that square, angles 90 degree, sides 4 cm or 5 cm. First one picture 4 cm, second one picture 6 cm, like that. In that rectangle, length any one 10, breadth 5. That is in another rectangle, length 25, breadth. That same ratio we need to maintain. 10 divided by 25, that is 10, here 2.5, no? Similarly 5 into 2.5, we need to multiply that particular product, or we need to divide. Suppose 30, 10, length plus 30, 10, another one 3, 1 also we can draw. Okay, similarly we can draw any other picture. Okay, state whether the following quadrilateral are similar or not. We can consider 1.5, 3, 1.5, 1.5, 3, 3, 3 automatically equal. Here 90 degree, here like a rhombus, it's not 90 degree, it's not a perpendicular symbol given, no? So automatically these two things are not similar. Okay, using this we are going to study some proof for that. First theorem, basic proportionality theorem. If a line is drawn parallel to one side of a triangle, if a line drawn one side of a triangle to intersect the other two sides, the other two sides in distinct points, that is DE. The other two sides are divided in the same ratio. The other two sides, that is, it's a parallel line, no? So other two sides means AB and then AC. It's in the same ratio. So AD divided by DB, AE divided by EC. Like that we need to prove. So here we need to consider this one. So for that, draw a triangle ABC and draw a line parallel to BC, that is DE parallel to BC. It intersects AB at D and AC at E. We need to prove that AD divided by DB equal to AE divided by EZ. Right. For that, I am going to consider this triangle. In this triangle ABC, these two lines are parallel. Now I am going to consider this line is the base. In that triangle ADE, this line is base. What about this one? Height. Why I am going to use? I am going to consider the area of the triangle. Now area of the triangle is nothing but 1 by 2 base into height. I am going to use this thing. So now I am going to consider triangle ADE. In this triangle, this is the base. AD is the base. Automatically this line is a perpendicular line. So this DE is a base. This AN is a height. So 1 by 2 base, that is AD into height AN. In the same way, I am going to consider other side AE as the base. So I am going to draw another perpendicular line. This is the perpendicular line, suppose. So what happened? Base AE means height DM. So 1 by 2 AE divided by DM. So I am returned. In that triangle ADE, I am going to consider two type of base AD. This side AD. So what is for height? This side. In that height base AE, this is height. That is, in this triangle, second triangle ADE, second part, AE as a base means AE into DM. Here already I am shown this. The same triangle. This is the height. So AD into EN. Okay. Next one is important. I am going to consider the triangle BDE. Why? We need to prove this triangle ADE and then this part we need. Similarly this part. So for that we are going to consider the triangle BDE. That next one DEC. This triangle. For first one BDE, we are going to consider the base BD. Suppose this is the base. Automatically the height, check that height is lies outside of the circle. That outside is nothing but we return already it's EN. Check, this is the base BD. In this triangle, now height lies outside. Already we studied. Suppose this is the scalene triangle. In this triangle, 90 degree lies that height from this base to height. Automatically, I need to draw a perpendicular line. How can I check? So from this part, 90 degree. So 90 degree here. That is vertex here. No, that is this is the height. So that is this thing lies outside. No. So for that, this height in this triangle height. You need to 90 degree, draw 90 degree, check, this one is outside. Similarly, in this triangle EDC, check the base EC. So base EC, automatically the 90 degree lies outside where this is. You understand? So please understand this one, this thing. So in this triangle also scalene triangle, that height lies outside. That is, this is the height. Okay, right. So for that triangle BDE, base BD, height, so EN. In this triangle DEC, base EZ, height DM. Please understand this. This height lies outside. We return this thing. We need to write. Now I am going to consider this side, that is ADE and BDE. So area of this ADE ratio, ADE divided by BDE equivalent to this area answer, that is side answer. 1 by 2 into AD into EN divided by 1 by 2 DB into EN. We can cancel EN and 1 by 2, that is AD by DB. Similarly, AD this side, this triangle and this triangle. So ADE and DEC. So DEC 1 by 2 EC into this DM. After writing the ratio, we can write DM 1 by 2 1 by 2 common, so we can cancel. So AE divided by EC, you can write like that. Now we are going to recall one thing. In that same parallel, between the same parallel, same base, and another one is a different. So already we studied this thing. Suppose it's a parallel line. Suppose this is a parallel line. We are going to consider this thing. Okay, we already studied this thing. Suppose this triangle. Okay, another triangle. So first triangle, so second triangle. Between the same parallel, same base. So same base of this triangle. This is the same base of this triangle. Means these two triangles areas are equal. We studied this thing in the 9th portion. So in the same way, suppose this thing is nothing but DE and AC are parallel. I am going to consider this shape, this two triangle. So triangle BDE and triangle DEC are on the same base. So how? Here I am going to consider this thing like that. DE as the base. So DE and height, no, this one. So base, this is one. So area of the triangle BDE, the same base but another vertex here. DEC, DEC, DEB. These two triangles are equal. If the two triangles are equal, means I can replace in any one for the first equation and the second equation. So suppose I am going to replace area of BDE equal to area of DEC. I am going to replace by first equation. So area of ADE divided by DEC equal to AD by DB. Already it is equal to A by EC. From 1, 2 and this 3, I can write area of ADE divided by BDE equal to area of this thing. That is AD divided by DB equal to AE by EC. You can replace in any one. So finally, these two sides are proportional. That is this thing we can write. So idea, we are going to consider the triangle. Just construct one parallel line. Introduce D and E. Consider the triangle ADE and the bottom triangle DEB and DEC. For that ADE base, this side base AD, so height EN. For this side base AE, height DM. For this as a scalene triangle, so here base BD, but here triangle, just in this triangle height EN lies outside. In this triangle height base EC, height lies outside, just DM. After that the ratio, so this side left side ratio and this right side ratio we can write. After comparing this we can cancel the common thing. After that we needed to write this thing in between the parallel, in between the same base, the same parallels, BC and D are parallel, no. So these two triangles areas are equal. So by this I can write area of BDE or area of DC. I can replace anyone. Suppose area of DC equal to area of BDE, I can replace here means ADE divided by BDE equal to AE by EC. Areas here AE by EC. That is area of BDE equal to AD divided by DB. So automatically this by 1, 2, 3 we can write this ratio AD divided by DB equal to AE by EC. Okay. Next, theorem, converse part of basic proportionality theorem or converse part of Thalles theorem. If a line divides any two sides of a triangle, first one we return or we need to give the statement if it's a parallel line, then the side AD divided by DB and AE divided by EC are proportional. But here already it's proportional. If the line divides any two sides of a triangle in the same ratio, if it's proportional or in the same ratio, then we need to show that then the line is parallel to the third side. The line parallel to the third side. We need to prove this thing. In a triangle ABC, we are going to consider this given statement up to this ratio. Draw a line DE such that AD divided by DE, AE divided by EC. Now DE is not parallel. So we are going to prove by converse part of this theorem. That is, if it's not parallel, we can consider one parallel line. So consider E dash. In any one side, we can consider E dash or D dash. Here we are going to consider E dash. E dash. So if DE is not parallel to BC, we are consider DE as parallel. We can construct. After that, we can use this given thing. AD divided by DB equal to E dash divided by E dash C. From 1 and 2, left side are equal. Automatically, right sides are equal. AE by EC equal to AE dash divided by E dash C. Now we are going to add 1 on both left side and the right side. AE divided by EC plus 1. AE dash divided by E dash C plus 1. AE plus EC, LCM. That is, we are going to multiply EC numerator and denominator like a number. AE plus EC divided by EC. Here AE dash plus E dash C divided by E dash C. AE plus EC, distance. AE plus EC, nothing but AC. So AC divided by EC. Next, E dash plus E dash C, nothing but addition, distance addition, AC, total length, divided by E dash C. Here EC, here E dash C. Not possible like that. How? Given different distance, no. How? Then the ratio, how it's possible to equal ratios? Suppose AC, total length, some 5 centimeter. 5 divided by this distance, suppose 2.5, distance is suppose 3. So 2.5, next 5 divided by 3. But we given as equal, not possible, no. Why it's not possible? We consider DE is not parallel to BC. It's not possible because of this. So it's possible only by this equal. So E and E dash definitely different points. So it should be equal. So that's why E and E dash must be coincide. So think about why it's, whether it's 2.5 means automatically this one 2.5. That is, this distance should be equal. How it's possible to equal this thing? A coincide. We return the converse part. We finally proved that it's not true. So that is, we needed to strike out this statement. That is, we consider E and E dash must be coincide. Okay. Using this, we are going to solve some example problems also. For the first example, if a line intersect sides AB and AC of a triangle ABC, D and E respectively. In that triangle ABC, D and E any points, it's given are parallel. D and BC are parallel. Prove that. Already we know that AD divided by DB and AE divided by EC by basic proportionality theorem. But we need to prove AD divided by whole thing AB, AE divided by EC. Right. The proof structure we need to study. So for that, first consider AD divided by DB for the basic proportionality theorem. Given DE parallel to BC, therefore by basic proportionality theorem AD divided by DB equal to AE by DE EC. We can consider like that. Add plus 1 on both sides. We can write AD divided by DB plus 1 means LCM AD plus DB divided by DB, AE plus EC divided by EC, LCM. AD plus DB nothing but AB. AC, that is AE plus EC nothing but AC, AC by EC. But we need to prove AD divided by AB, but here AB divided by DB. AB numerator, here AB denominator. Right, be careful, AB denominator, but AB here numerator. And also AD, this part. We have DB bottom part. That is DB is a bottom part. So AB, how it's possible? If you are going to add 1 AD plus DB, definitely AB is a numerator. Suppose I am going to take the reciprocal of this one, automatically AB comes to denominator. Okay. So for that, first itself take the reciprocal. So AD divided by DB equal to A by AC, as DB divided by AD equal to EC divided by AE. Take the reciprocal. After that, add plus 1. So DB plus AD is nothing but AB. EC plus AE nothing but AC. AB divided by AD equal to AC divided by AE. We return AD divided by AB we need to write, but we return AD divided by AB. So that is reciprocal. So finally once again take the reciprocal. So AD divided by AB equal to AE by AC. We can take the reciprocal. Because of 1 by 2 equivalent to 5 by 10, we know that the same proportional. Suppose we are going to take the reciprocal. 1 by 2 as 2 by 1, 5 by 10 as 10 by 5. That is 2. Here after cancellation this is also true. So we can take the reciprocal. So idea I am given. In that same question they can ask this one also or this one also. What is the idea? Here AB it's in numerator or AB it's denominator. Which part it's given? So like that try to start to solve the problem. So AB it's in denominator. So we need to write AB in denominator, means we need to write the first itself reciprocal. Then only AB possible to write in denominator. So I am given the two things. No need to write this one. We can write this answer. But study both things. Example. Next example. In that trapezium ABCD, with the AB parallel to DC, E and F are the points on non-parallel sides. This AD and then BC are non-parallel sides. EF is parallel to AB. Show that AE divided by ED, BF divided by FC. We are going to prove this thing by using triangle, because this thing only we know that. So think about parallel things are given. So now consider the triangles. For that, how it's possible? Join the points AC. That is, join AC. It intersect at G in that line EF. So join AC, it intersect EF at G. We need to write this thing. So now already given AB parallel to DC and also EF parallel to DC, EF parallel to AB. That automatically EF parallel to DC. So that is EG parallel to CD and GF parallel to CD. Now consider this triangle ADC. AE by BD and AG by GC by using basic proportionality theorem. Similarly, in this triangle, just study this thing. So base suppose CF divided by FB or BF divided by FC equal to, consider the same order. CF by FB means CG divided by GA, or BF divided by FC, AG divided by GC, anyone. Okay, so return CG divided by GA, GC divided by GA. We need to write as per this. We can write the distance now GC equal to CG. So CG divided by GA as CF divided by FM. Return this thing, after that I am going to change. So I can write GC divided by AG because of this equal to FZ divided by BF. Distance we can change. Now compare this thing. Here AG divided by GC, but GC divided by AB. So I am going to take the reciprocal of this thing. So AG divided by GC equal to BF divided by FC. Equating these two, one side are equal, AG and AG, this side are equal, that is AE by AD equal to BF by FC. So AE by AD, AE by AD, BF divided by FC. So idea, in that trapezium we are going to construct one thing already given. This EG here, EF is parallel to AB, that is already AB and CD are parallel. So parallel sides all are parallel means one comparison of two lines are parallel. Three lines are parallel by using that pair. Suppose this line are parallel. The same way this line and this line are parallel means automatically this line and this line are parallel. Consider the 1, 2, 3 lines. First one, second one parallel. Second one, third one are parallel means 1 and 3 are parallel. Like that, AB, EF, DCD are parallel. We written. But in this triangle, we are going to use basic proportionality theorem, AE by ED, AG by DC. Similarly, just it's in reverse form, but we can write here A one vertex, no, like that, CG divided by GA, CF divided by FC. After that, we can check it's in a reciprocal form. So we just take the reciprocal. After that, compare. So we can write A by ED equal to BF by FC. Okay. Next example, PS divided by SQ, PT divided by TR. That is converse part of Thaller's theorem or basic proportionality theorem, theorem 6.2 given. So we can consider, right, this ST and Q are parallel, okay, and angle PST equal to angle PRQ. These two angles are equal. Prove that PQR an isosceles triangle. So isosceles triangle property we need to study. How can we tell one triangle is isosceles triangle? If the base angles are equal. Suppose these base angles are equal, this triangle is isosceles triangle. Suppose this base and Q are equal means this PQR is an isosceles triangle. So we need to prove these base angles are equal, or this sides PQ and P are equal means this is isosceles triangle. Now consider the statement, ratios are given, automatically this ST and then Q are parallel, we can use by theorem 6.2. Now given this angle PST and then PRT are equal. Now consider the parallel line. So in that parallel line, any one transversal intersect, automatically these two angles are corresponding angle. These angles are corresponding angle, this bottom are corresponding angle. So now we need to consider this, that is these two angles are equal. Already these two angles are equal, but now these two angles are equal means these two things are equal. So now angle Q, that is PQR equivalent to angle PRQ. So this thing PST and PRQ, angle PST angle PRQ equal given, that is angle PRQ equivalent to PQR. So that is these two angles are already equal. So we now proved that these two angles are equal by using the transversal corresponding angle. So automatically these two angles are equal. Suppose these two angles are equal means this side PQ and PR are equal. So automatically the triangle PQR is an isosceles triangle. So triangle PQR is an isosceles triangle. Thank you.